Good day, students. In this clip, we're going to be going over how we can apply the related rates differentiation procedure to certain functions that always show up when you're working with related rates problems. All right, we're going to be focusing on some basic formulas from geometry. So let's start off with the first one, which has to do with uh, right triangles. All right, so what does differentiation with right triangles involve when you're working with related rates problems? The first situation involves a case where you have a fixed hypotenuse. A fixed hypotenuse. When your hypotenuse is fixed, is a situation where an example is a ladder situation. If, for example, the ladder is sliding down a wall, the length of the ladder does not change, but the velocity of the top and the bottom of the ladder changes. Okay, so let's say we have a situation like this, and we have a right triangle, and this hypotenuse is a constant. Let's say its value c. This changes. Let's call that x, and let's call this y. Okay, so in this case, the formula that relates all three sides is the Pythagorean theorem. C squared is equal to y squared. Let's do x squared first. C squared is equal to x squared plus y squared. All right, so when you're doing related rates problem with this, you differentiate uh, all both sides with respect to t. Okay, so you're going to have d dt of c squared is equal to d dt of x squared plus y squared. Okay, so we're differentiating with respect to time. Now, since this is a constant, it's going to end up in 0 equals, now differentiate these ones individually. So you're going to have 2x using the chain rule, dx dt. Notice that the variables are not matched, so you have to do it with respect to this variable right here. Plus, differentiate y squared using the power rule is 2y dy dt. All right? So this is a differentiated form. Now what we can do is we can solve for dy dt. If we solve for dy dt, all we have to do is subtract 2x dx dt to the other side and divide by 2y. If I subtract 2x dt from both sides, I'll have 2x dx dt. And then when I divide by this 2y is going to end up down here. Okay? So if we do that, we can then notice that this 2's divide out, and it's going to be equal to negative x over y dx dt. All right, so that's the formula for dy dt. Now, what if we wanted to do dx dt? It's going to be very similar. Dx dt is simply going to be the same procedure, but we're going to move 2y over first, so our final answer will be negative y over x dx dt. Okay, so these are the formulas you have when you're dealing with right triangles. Okay, so this is y dt, this is dx dt, and that's dy dt. All right, let's shift our attention to a situation where the hypotenuse is not a constant. Okay, so we have a fixed hypotenuse situation. What if we have a variable hypotenuse? Variable hypotenuse. Now, what would the derivative situation look like? How would we differentiate with respect to time there? So let's draw a right triangle. Now, can you think of an example where everything is changing? This could be a situation where a rope is being used to pull in a boat to shore, or maybe a balloon is being released into the air. So situation involving a rope. Okay, so in this case, we're going to have this is y, this is x, and this will be s. We can call s the distance or the length of the rope. In this case, the formula that relates all three is s squared equals y squared plus x squared. If we differentiate with respect to time, we're going to have 2s ds dt is equal to 2y dy dt plus 2x dx dt. Alright, if we'll get ds dt isolated, we're going to have ds dt is equal to 1 over 2s times 2y dy dt plus 2x dx dt. Alright, and you notice this 2, if you factor out, if you distribute 1/2 to all of them, this 2 cancels this 2 right there and that 2 right there. So the SDT is simply going to be 1 over s times y dy dt plus x dx dt. Okay, so that's the differentiation formula if the hypotenuse is a variable. All right, let's shift our attention to the related rates formula for a circle. Okay, so we're done with right triangle. Let's take a look at the circle. Now, when you're dealing with circle problems, you're either going to be looking at the volume or the area. Let's deal with area first. So for the area of a circle with radius r, we know what the area formula is. A is equal to pi r squared. So how do we differentiate this with respect to time? We have only one variable here, which is nice. So we're going to have the ADT is equal to 2 pi r, applying the power rule to r squared, and then using the chain rule on r, dr dt. All right, so that's that for area. And then the next thing is for circumference. What is the formula for the circumference of a circle? Circumference of a circle C is equal to 2 pi r. Okay, so how do we differentiate this with respect to time? The c dt is going to be 2 pi, the derivative of r is 1, and using the chain rule, the r dt. Okay, so the c dt is basically 2 pi dr dt. How about if we have a formula that is a combination of area and circumference? How can we deal with that? How can we write that out? If you have a combination of the area and circumference, what's going to happen is as follows. You will have, if you notice, the area formula has a 2 pi and a dr dt, and 2 pi and dr dt is basically what the c dt is. Okay, so let's rewrite the ADT. The ADT is 2 pi r dr dt. And if we move things around, we have the ADT is equal to r times parenthesis 2 pi dr dt. Now what can we replace this with? This is the same thing as the CDT. So the ADT does have a related to the change in area. So the in circumference, sorry. So the ADT is equal to r dc dt. So this formula relates the area and the circumference together. And this is just pure circumference and this is pure area. Okay, let's shift our attention to a square. What if we have a square, a situation involving a square? So let's say we have a square of side length S. We know what the area and their perimeter is. So let's do the area first. So the area formula of a square is simply length times width, but the length and the width are the same. So we have A is equal to S squared. So what is the related rates formula for the area and the length of a side? The ADT, you know, the derivative of A is 1, the ADT equals 2S, and using the chain rule, the S dt. Alright, so that's that. Now how about the perimeter of a square? Perimeter of a square is given by, let's say P is equal to 4S. So if we differentiate this with respect to time to see the related rates, formula between the perimeter and the side length. The PDT is equal to derivative of 4s is simply 4. Derivative of s is 1. ds dt. Okay, so that's the related rates for perimeter and area. Now what if we wanted to compare the rates of the area and perimeter together? So the area and perimeter, how are their related rates connected? So for the area, we know is we can write this as we know that the ADT is equal to 2s ds dt. Now, how can we put this into this equation right here? We know that the PDT is 4 ds dt. So let's see, what can we do here? We can write this as what is the relationship between 4 and 2? If you take the half of 4, you get 2, right? So we can write this as, take out the s, and then times 1/2. 1/2 of 2, I'm sorry, 1/2 of 4. 1/2 of 4 ds dt. Now let's take a close look at what just happened here. If you take half of 4, you're going to end up with 2. Okay, so that's why I put the 1/2 here. This is exactly the same thing as that, but it's written in a formulation where I can input the PDT. Okay, so the ADT is simply going to be S over 2 dp dt, because we know that 4 ds dt is equal to dp dt. So this is the formula that shows the relationship between the area and the perimeter of a square. All right, next thing we're going to look at is the sphere. Okay, sphere. So let's start with the surface area. Surface area. So we're going to call that S. So S, surface area of a sphere, is given by 4 pi r squared. So what are the related rates? How do these two variables, the surface area and the radius, change with respect to time? To do that, we're just going to differentiate both sides. So the derivative of S is 1 times ds dt is equal to 4 pi. Derivative of r squared is 2r. Using the chain rule, dr dt. Okay, and then we simplify, we have ds dt is equal to 8 pi r dr dt. So this is the relationship between the surface area and the radius. How about the volume of a sphere? The volume of a sphere is given by 4/3 pi r cubed. So what are the related rates here? Differentiate both sides with respect to time. dv dt is equal to 4/3 pi, and then the derivative of r to the third is 3r squared times 3r squared, and we do not want to forget the r dt. Okay, so dv dt simplifies into, these 3's cancel out, 4 pi r squared dr dt. Now what's the relationship between the surface area and volume in terms of related rates? So surface area and volume. Alright, so how can we relate it? Let's start with the surface, with the volume, the one of higher dimension. dv dt is equal to 4 pi r squared dr dt. Alright, so we have 8 pi r dr dt, so let's start off by factoring out an r. Now how do you get 8 from 4? If you take half of 8, you get 4, right? So if I put a 1/2 here, 1/2 times 8 pi r dr dt. This expression I just derived is the same as that, because r times r is r squared, and then half of 8 is equal to 4. Alright, now written it in a form where I can substitute dSdt in here and clearly see the relationship between the change in volume, instantaneous change in volume and instantaneous change in the surface area. So the VDT is going to be R over 2 times ds dt. Okay, so that's what relates to volume and surface area. Alright, so the next related rate formulas we're going to look at is we're going to go, we're already in 3 dimensions now, we're going to look at the cylindrical prism. Okay, what if we have a circular prism? Not a cylindrical prism, a circular prism. Alright, so for a circular prism situation, I'm going to be looking at the surface area and the volume and also how they're connected. So for circular prism, let's go ahead and sketch it. Alright, so there goes the circular prism. So let's say it has radius of r and the height of h. So we have radius r and height of h. Okay, let's start off by taking a look at the surface area. The surface area of a circular prism is given by, called S equals the area of the top and the bottom, 2 pi r squared plus the lateral height, which is 2 pi rh. Okay, the circumference is the length of the lateral area if it's expanded into a rectangle, and then h is the height. Okay, so there goes the formula. So what is the related rates of this formula if we differentiated each one with respect to time? So the derivative of s is 1 times ds dt equals, this becomes 4 pi r dr dt, because when you differentiate r squared, you have 2r, and then you multiply the 2 by this 2 right here, and you get 4. Plus, this one differentiated, we're going to have to use the product rule here. Okay, so we have 2 pi, and then in this case, this is u, and this is v. I'm going to use this variation, uv prime is equal to v u prime plus u v prime. All right, so it's going to become 2 pi times v, which is 8. U prime is derivative of r is just 1, the r dt. Okay, plus we still keep that 2 pi, and u is r, and then the derivative of h is 1, the h dt. Okay, so let's simplify it. We have ds dt is equal to 4 pi r, the r dt, plus 2 pi h, the r dt, plus 2 pi r, the h dt. Okay, so that's the formula that relates to surface area. Now, if you take a look at this equation, if the radius is fixed, the r dt is going to go to 0, so these two terms cancel out, and you're going to be left with 2 pi r dr dh dt. If the height is fixed, the h dt is going to be 0, so this term will be gone, and it will be left with these two components. All right, so that's that. All right, let's take a look at the volume of a sphere, of a circular cylinder. The volume of a circular cylinder is given by the area of the base, which is pi r squared, times the height, which is h. Now, what is how are these rates related if we differentiate with respect to time? The v dt is equal to, now we're going to have to use the product rule here again. R squared is going to be u, and h is going to be v. So we're going to have pi, you know what the derivative is, v, which is h, times u prime is 2r, the r dt, okay, plus, let's keep the pi there, pi times u, which is r squared. The derivative of h is 1, dh dt, like that. Okay, now let's simplify it. We have dv dt is going to be 2 pi rh dr dt, and on the right side this will be plus pi r square dh dt. Okay, so this is how the volume is related to the sides. All right, so the last shape we're going to look at is a cone. It's very common to come across cone problems when working with related rates. So we're going to look at the surface area. I'm sorry, we're going to look at just the volume of a cone, okay? So let's look at volume of a cone. So what is the formula for the volume of a cone? Well, let's go ahead and make a real quick sketch of a cone. So let's say it's something like this. All right, let's say it has a radius of r and the height is h. So the radius is r and the height is h. So what is the formula for the volume of a cone? We know that the volume of a cone fills a third of a um, circular prism of the same height and base radius, right? So the volume is what we're going to be looking at first, and then the formula for volume is 1/3 times the area of a cylinder of the same base with the same base and height, which is pi r square h. Okay, now let's go ahead and see how the rates are related if we differentiate with respect to time. So we have dv dt is equal to, we're going to use the product rule here, 1/3 pi. Now this is u, and this is v. And then we know what the product rule is, right? vu prime plus uv prime. So 1/3 times v, the derivative of u is going to be 2r dr dt using the chain rule, plus, we have to keep the 1/3 pi, it's distributed, u, which is r squared, times the derivative of h1 using the chain rule, dh dt. Okay, so let's write this nicely. So dv dt is going to be 2/3 pi rh dr dt plus 1/3 pi r squared dh dt. Okay? So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here. More clips can be found on mathcoachserve.com. Thanks again for watching and have a wonderful day.